Hello, I'm David, and I'm the coordinator of the Maths Learning Centre at the Uni of Adelaide. I'm going to have a go at a geometrical proof using vectors. And the proof I'm supposed to be proving is prove that the midpoints of the sides of any quadrilateral form a parallelogram. Let me just attempt to understand what that means. So I get like a quadrilateral, which means it has 4 points connected by 4 sides. And I guess no 3 of them could be collinear because then it'd be a triangle. And then I do the midpoints and I connect them up. And it's supposed to be a parallelogram. So a parallelogram would have opposite edges parallel. Okay. I wonder if it's allowed to have your quadrilateral like a dart shape. There's the midpoint, 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 midpoint. Oh, cool. Okay, so I get the idea. So somehow I'm supposed to do this using vectors. So I suppose what I'll do is say let A, B, C, D be 4 points making a quadrilateral. I'm going to draw it on this diagram. Okay. And then the midpoints of the sides, I guess I'll give them names. MN, no, that's not going to work. KLMN, that'll work. Let K be the midpoint of AB. L be the midpoint of BC. M be the midpoint. Oop, that is not how you spell midpoint. Of CD, and N be the midpoint of DA. Okay, so our goal is to show that KL, LK and MN are parallel and that LM and KN are parallel. And actually, if they're an actual parallelogram, they won't just be parallel, they'll actually be the same length as well. So the vectors from M to L or L to M is the same vector as the vector from N to K. So that's useful. Okay. Right, so somehow I have to show that the vector from L to M is the same as the vector from K to N. Okay, and the same the other way around. All right. Let me go from L to M. So to get from L to M, oh, the arrow's pointing the other way. I'll go from M to L because I'll just get confused otherwise. M to L. Then I guess I could go from M to C first and then from C to L. Okay. Rightio. And that's the same. I guess I could also instead go this way. I could go from M to D and then from D to N. So D to A along here, and then from A to B, and then from B to L. I don't really know how that helps yet. But what if I try to see what happens if I go do N to K as well? So from N to K would be from N to A, plus from A to K. Or it could also be from N to D plus from D to M plus from M to, no, I don't need to go to M. I could just go all the way to C, from D to C plus from C to B plus from B to K. Does that help me at all? I mean, I need to show that this is the same as this. I haven't used the fact that they're midpoints yet, so that might help. Okay, so I guess if they're midpoints, then I do know that from M to D is going to be half from C to D. So I could try and do all the things that are like half things, like all the vectors that are half of an edge to say what they're half of, I suppose. All right. So ML is MC, which is half of DC, and it's CL, which is half of CB. Okay, and it's also equal to MD, which is half of CD, plus DA, which is fine, plus AB, which is fine, plus BL, and BL is half of BC. Okay. And then NK would be NA, which is half of DA, plus AK, which is half of AB. And NK is also equal to ND, which is half of AD, plus DC, which is fine, plus CB, and then plus BK, which is half of BA. Okay. I do know that like this half of DC and half of CD, they're in opposite directions to each other. And they're the same length because DC, like DC and CD are the same thing, right? So they're the same length and they're opposite directions. So if I added them together, I'd get 0, and the same thing happens here. Okay, so 2 lots of ML is DA plus AB from these two equations here. And 2 lots of NK is, by the same reasoning, DC plus CB. Wait, but DA plus AB is the same as DB. And DC plus CB is the same as DB. Okay, so 2ML is the same as 2NK. And so ML is the same as NK, which means these edges here are parallel. And the same argument, but round this way should work for the other ones. So that's really cool. It feels like a lot of work though. Like maybe there was a quicker way. I did use the vector DB. So if I chucked this in, maybe my proof could have gone instead, like not have these bits, and my proof could have gone instead that that dA plus AB is the dB that we're looking at. So LM equals half of CB, that's this journey here, plus BD. I'm doing it the wrong way around. I should do ML just to make it easier on myself. ML is half of CD plus DB plus half of BC. Okay. That's coming around this path here. I don't see really a better way. Like it's not that much better. Yeah, I don't see how that's all that much better. But I guess, maybe if I did the NK in a similar way, but come around this way and come past here. So the NK would be like half of AD plus DC plus CB plus half of BA and no, it's not helping. Well, I have a proof, so I might leave it at that. I just felt like it, I don't know, it just looked a bit clunky. But I do have a proof, so I'm just going to leave it at that. Okay, it's a proof. What can I learn from this proof? I mean, I was trying to use a strategy where you run through vectors in two different ways, and that helps you to learn some stuff about how the vectors are related to each other. And I had to actually combine those two different ways into one thing in order to make it work. And I really just wish there was an easier way that involved MNL and NK in the one thing, because if they're equal, then it should be possible to do, if I did one forwards and one backwards, they would add up to 0, I guess. I was just hoping that I could make them equal to the same thing. Like this one looked promising, but it doesn't seem to get there. So I don't know, I just feel a bit unsatisfied. I guess I'll just leave it at that.